So now we're doing Learn GDScript from Zero by GDQuest, and we're on this lesson right here. All right. So as programmers, we rely a lot on a lot of code created by others before us. True. Every programming language comes with a wealth of features created by other programmers to save us time. Also true. We call a bundle of code created by fellow developers a library, all right? And it's a bunch of code sitting there just waiting for us to use it. Game engines like Godot bundle many libraries together. They provide a massive tool set to save us time when making games, all right? We'll always use a lot of existing code. When coding, we always use a lot of code from developers who came before us. True. In a moment, we're going to write our first code. We're going to use functions created by the Godot developers. A function is a list of instructions with an exact name. We can tell the computer to execute the instructions in sequence with that name, right? So calling functions right here. When we tell the computer to execute a function, we say we call the function, right? To call a function, we write its exact name followed by an open and closed parenthesis. To call the function named show, we would write show with the parentheses like that, all right? All right, so in Godot, calling the show function makes something visible, like a character or item. The complementary hide function hides the entity. Once an entity is visible, calling show again doesn't have any effect, right? Similarly, once we hide something, calling hide again doesn't change anything, right? So now we're going to click the run button on any example below to execute the code listing. Okay, anyway. So yeah, we're going to run this run function and, we're going to define this run function, and it's going to call hide. And so this function, when we run it, is going to run the hide function that's already been defined to hide this thing, right? So let's run it. There it is, all right? So in the code listing above, we write the function call hide like this in a new function named run, okay? To execute the code, creating a new function is necessary to execute instructions in GDScript, right? So can they tell us more about that run function? Yeah, okay, anyway, let's read this. So in GDScript, unlike in some other languages, we must write our code inside of custom functions. Okay, so yeah, that's one thing going on. I think we're going to have to make new functions just to run pre-existing functions. Built-in functions, I mean. That's wild, but okay. We're going to learn what functions are and how they work in great detail in the course, but here's a quick look at them if we're curious. A function is a bundle of code we can execute anytime. It's a named list of instructions. To define a function, we need to write the func keyword, the function's name, parentheses, and a colon. So it's going to look like this: func run, parentheses, and a colon. And this is going to define a function named run. We then go to the next line to write the function's body, and that's the instructions of the function, all right? So notice how each instruction starts with a leading tab character. The computer uses that to know which lines are part of the function. Throughout the course, we'll see many functions called run, okay? Those are functions we created, or they created, to give us interactive examples. There we go, all right. So now we're on to function arguments. We use parentheses to call functions because we can give the function arguments inside the parentheses. What? We can give the function arguments inside the parentheses when calling it, right? Let me read that one more time. We use parentheses to call functions because we can give the function arguments inside the parentheses when calling it, right? So basically, when we look at this right here, this part of this code right here is the argument, right? So here's a sprite standing straight. If we call the rotate 0.3 function, the character's sprite turns by 0.3 radians, all right? So we've got this right here, rotate, and then by 0.3. We run it, and there it is, tilted like thus, all right? So the 0.3 part between the parentheses is the function's argument. Arguments are values, numbers, bits of text, and more that change how the function behaves, okay? Arguments let us fine-tune the effect of the function call. They can be optional at times, but functions often require arguments in order to work. True, because if you're putting like a measurement in for a function that does something with that measurement, you know, it's going to change pretty much every time. It's going to be like this big, and the next time it's this big, and the next time it's this big. You know, those. That's what I'm talking about. Anyway, let's get back to it. For example, calling rotate without any argument would result in an error. Without an argument, Godot doesn't know by how much we intend to rotate the sprite. True. But we don't have to worry about memorizing what arguments each function requires or accepts. As a programmer, the documentation will always be close by for us to refer to. All right. So finally, we're going to notice how we use a dot in the number 0.3 above. We need to use a dot like this to represent decimal numbers. We can't use commas as they have a different purpose in code. True. Also, we got to talk about radians. So the value of 0.3 is an angle in radians. In daily life, we're used to measuring angles in degrees. True. The radian is another scale commonly used in video games and math. We can convert radians into degrees by multiplying them by 180 and dividing them by pi. Of course we can. Degrees equals radians times 180 divided by pi, all right? The angle of pi radians corresponds to 180 degrees. And so 2 pi is a full turn, 360 degrees, all right? Remember 2 pi r? That's how you get the, what is it? The diameter, right? Not the diameter, the perimeter. Pi r square, what's pi r square? Is the area. 2 pi r is the perimeter. The perimeter. The perimeter is the parameter. All right. Back up. Let's go back. How do radians work exactly? Radians are a way to measure angles based on the radius of a circle. True. To get the angle in radians, we take the circle's radius and wrap it around the circle. That angle is 1 radian because we're wrapping the radius 1 time around the circle. Because the perimeter of a circle is 2 pi times pi times radius, a full turn 360 degrees corresponds to 2 pi radians. We need to wrap the radius of a circle 2 times pi times around the circle to make it a full circle. True, because it's 2 pi r, right? Of course. So yeah, there we go. What does the code below do? Select all that apply. Select all that apply. It got me the first time, this piece of work. It makes the entity like a game character or sprite visible. It does that, yes. It calls the function name to show. It also does that. Select all that apply. Submit it. There we go. We're right. Both the answers are right. Technically, the code calls the show function, yes, and doing so makes the game entity visible. True. Let's keep going. All right, another example. With the move local x function, we can move the character to its left and right. The function takes 1 argument, a number of pixels to offset the entity. The complementary function, move local y, makes the character move up and down. True. All right. So this is one way to move a character in a game, although we'll see more powerful ways to do this later. All right. So let's do this. Run it. It moved to the right and it also moved down. Why did it move down? Why? This moves the character down. Why is that? Let's go look. With positive values, 20, the code above moves the robot to the right and down. This is probably different than what we would studied. Pardon me. This is probably different from what we studied at school. In math classes, the horizontal axis points to the right, like here, but the vertical axis points up. What's up with that? In video games and generally in 2D computer graphics, the vertical axis points down instead. So whenever we move something on the y-axis with a positive value, it'll move down. Turns out. All right, and why is that? I don't know. We might figure it out in a couple of years. How do we call a function? What is the syntax we use to call a function in general? We write a value like a number followed by an opening and closing parenthesis. A number? No. We write its name followed by an opening and closing parenthesis. I like the sound of that. We write its name followed by a colon. No. Submit. We're right. To call a function, we need to write its exact name followed by an opening and closing parenthesis. In the function, if the function requires one or more arguments, we add them inside the parentheses. Pardon me. Whether we need to do that or not depends on the function. True. All right. So now we got some practices. All right. We're going to make the character visible. The robot's invisible. We'll call the function to bring it back, okay? We're going to make the robot upright. The robot is turned sideways. We're going to help it straighten up with a function call. Practice. Let's go with the first one. Make the character visible. Goals. The robot character is invisible, so the rook is actually a robot, turns out. Call the show function to make it appear. Please call the show function inside the run function on line 2, and keep the tab character at the start of the line. This one right here. That one right here. Let's keep it right there. The computer needs that to understand the code. True. Hints. Hint 1. Our code should call the show function inside the run function. Okay. So show. Show. Boink. Just like that. Do we have to cap it off with a semicolon? I don't think we do. Run it. Looks good. And continue. And here we go. Make the robot upright. Goals. The robot was turned by negative 0.5 radians. We need to make it upright by calling the rotate function. We're going to call the rotate function inside the run function on line 2, just like we did in the last one, and keep the tab character at the start of the line. The computer needs that to understand our code. I don't think we need the hint. I think we get this one. Rotate. But we got to do it. We got to make it stand right side up. So we're going to have to say 0.5. You know what? Let's try it without the 0. How about that? Let's see what happens. And continue. And there we go, and continue yet again. And now we're on to drawing a rectangle. And we'll see you next time.